Hello. Welcome back to the continuing lecture series in investments. This is Dr. Jeff Holm, and we've been reviewing stock valuation models since our last class, since our last video, actually. So we discussed how the constant dividend model or zero growth model is derived in our last video using a technique called the infinite geometric series. And we all know now this time what constant dividend growth model is about. It's about, it's also called Gordon growth model, right? AKA Gordon growth model. Or just Gordon model. And well, obviously, somebody named Gordon developed this model. That's why it's called Gordon growth model, right? Actually, an economist named, I forgot his first name. It must have been Robert Gordon, or because there are two Gordons among famous economists. One is still alive. The other one passed away. The owner of this, the author of this model, and he published this model in 1950s. So, and that Professor Gordon, passed away, I believe, at least, in 1990s. But our question is, we all understand what this model means. D1 is dividend at time t plus 1. Of course, so it is not exactly D1. It is, actually expected D1, right? Which is expected at time 0, right? Because you're making a one period forecast, so it's expected at time 0. And it's not difficult to make that forecast. It's simply, if you know the growth rate of the dividends, right? We can easily make a forecast by making one, a compounding, one period compounding, right? And therefore, our first question is, how do we calculate this growth rate? Of course, the data must be given, right? Without the dividend data for the last like 5 years, or even for last 5 years, there would have been only like 20 dividends, because dividends are paid quarterly, or annually only 5 data points, right? So to ensure statistical reliability, we need at least to make uh, to make it statistically valid and reliable for normal distribution, we need at least 30 data points. But 30 data points would mean what? Six uh, at least like 7 to 8 years worth of data quarterly, in terms of quarterly. So but let's say even if you have 5 years worth of data, then we got like 20 data points. But if you have the data of dividends, we can calculate the average growth rate of dividend, which is basically geometric average, right? Because you cannot use simple average; it has to be geometric average. And our next question is, why does it look this in the denominator? Why is it required return minus growth rate? I mean, why do you have to subtract growth rate from that? I mean, first of all the models start from, right? All the models start from this polynomial, right? Which is basically discounting model, right? Up to time horizon, some finite time horizon or infinite time horizon, right? But how does this 1 plus k raised to n, how does that 1 plus the discount factor, right? How does that 1 plus k 1 over n, how does that turn into k minus g, right? That step is missing in most textbooks. They just give you the final result, right? Final outcome, but never give you the steps of derivation, how they arrived at this final result. So once again, this is 300, finance 300, not 100. I already also showed you how this result, how you arrive at this result in finance 100, but I didn't make it mandatory for you to derive it yourself, right? But this is 300, so on this level, you should be able to derive it yourself. So basically, to do that, I will have to find a I'll show you basically how it is done, but I will have to go to a I'll have to use another file. Let's see if I can find it easily. It will take me some time to find it. Just bear with me. I have to pull up this file. Where is it? Let's see. No, this is not it. Okay, yeah, I found it. So let me quickly switch the shared application. Let's go to yep, and then all righty. I hope you can see this. Can you see this? Yeah. So this is how Gordon growth model is derived. First of all, let's think about it. I told you last time. I cannot write on this. Let's see if I can. Oh, okay, I don't think I can write on this because this is a PDF file. Now, remember last time I said, if this is one period compounding, right? But if it is, purely, it's just growth rate. I mean, if this is not K, but if this is G, right? If this is G, then you won't have, D dividend here. It will just have, growth in the price is just growth in the price. So in other words, if this was G, let me see if I can. Edit text, maybe. No, it's not it. But let me keep the or highlighter. At least I want to use highlighter. I use highlighter. Yes. Let's do this. So if this was G, no, this is PDF file. It doesn't allow me to do that. What can I do? I'll just bear with me. So if it wasn't K but G, right? In the future, right, you will have only PT plus 1. And the reason, the only reason that that this in the left-hand side you have dividend at time t plus 1 is because we have K here. In other words, that's the difference between the return and just the growth rate. Excuse me. So the point is, suppose we are solving it for, suppose we are solving it for eventually for PT, but we can at least isolate, before to solve for P, right? We can isolate P, PT sub T, right? But just for now, let's isolate 1 plus K. Of course, then divide the left-hand side by P sub T, and then in the left-hand side we can um, uh, we can replace PT plus 1 by its own definition. What is PT plus 1? PT plus 1 is PT times 1 plus growth rate. Now think about it. I told you if this was growth rate, then the left-hand side will be only PT plus 1. So, and then, dt plus 1 will still, tag along. And then if you distribute PT into this parenthesis, then first it's going to be PT plus then, G, right? PT times G, right? But PT plus PT over PT will cancel out. It will become 1, right? PT over PT will be 1. And then PT times G over PT will be G, because PT and PT will cancel out. And dt plus 1 over PT will remain as dt plus 1 over PT, right? Because this is additive term, you can just break up that fraction, right? And then we rearrange, these terms, move these, 1 plus G to the other side, and then 1 and 1 will cancel out. G will change sign, will become negative. So on the right-hand side, it's going to be K minus G. And then in the left-hand side, it's just dt plus 1 over PT. If you solve it for PT, then what does it become? It's going to become dt plus 1 over K minus G, right? K is, also, in other words, required return. Okay, everyone is clear about this? This is basically how Gordon growth model is derived. Actually, when Professor Gordon actually developed this model, he derived it in a slightly different way. This is my version, because this, to me, it looked very, simple and straightforward and, lucid. This is how I derived it. When I was a graduate student, this is the way I cracked it, because it looked, for me, it was a really, a mystery. Why in the lower, denominator, how did that G, come into the denominator, right? So, and as a doctoral student, I try to crack it, and I cracked it. Okay, so there you go. That's the steps of derivation. Now I'm gonna switch back to okay. So that's how that is how Gordon growth model is derived, and you should be able to do that too. And our next question is then, we cannot assume that growth rate will be given all the time, but if you have, as I said, dividend, if you have like, dividend data for at least for the last 5 years or 20 quarters, we can do that. For example, so we gather dividend data, right? Let's say year 5, 4, 3, 2, 1. And if you have dividend, if the dividend is in reality, right, dividend cannot be consistently growing, right? Dividend would be uneven, right? Sometimes it's growing, sometimes it's dropping, but even, overall, but the trend should be growing. But then they wouldn't be growing at a constant rate in reality. But that doesn't matter, right? We take the geometric average of for that growth rate. Okay. Now, so the implication. The implication of dividend discount model in general is that expected return is actually expected return consists of dividend yield and capital gains yield. Okay, what is dividend yield? Dividend yield is dividend over current market price. What is capital yield? Oh, of course, that's capital gains divided by, right? Capital gains divided by current market price. And capital gains yield is exactly the growth rate, if you think about it, right? If you do this, that's growth rate. Now, because we now it came to dividend yield. If you remember something similar, there's something similar. What is current yield? Anybody? Current yield is short-term bond yield, right? This is a bond terminology, right? Yield to maturity is a long-term yield. Current yield is short-term yield. And how do you calculate current yield? Current yield is simply annual coupon payment divided by current market price of the bond, right? So you see, this is like a counterpart, right? Bonds counterpart to stocks dividend yield, right? Now, again, there is something called earnings yield. What's earnings yield? Now, this is something similar to dividend yield, but there's a stocks concept. Earnings yield is EPS. What's that mean? What does that mean? Earnings per share, right? Over. I will use P because it's market price rather than market price of the stock. But if you think about it, dividend is part of the earnings per share, right? Dividend is part of earnings. So earnings yield is always supposed to be greater than dividend yield. I mean, mathematically, it's bound to be greater than dividend yield, unless they pay out 100% of earnings as dividend, right? Now, but another interesting thing is, if you flip this, flip it, in other words, inverse, right, to -1, that becomes what? If you flip it, it becomes price-earnings ratio. Isn't that right? Price-earnings ratio. Isn't that right? But then, price-earnings ratio is, so the reciprocal of the price-earnings ratio is, then think about it, earnings-price ratio, right? Reciprocal of price-earnings ratio is earnings-price ratio. Yeah, in concept, that's correct, but they don't. They can call it earnings price ratio, but they call it earnings yield, more. But it's quite obvious. It's earnings ratio, and price is proportional to dividend, right? From the implication is that the price is proportional to, of course. Now think about it. Price is a portion of, this is the intuition. Price is part of the earnings per share. And if earnings per share goes up, think about it. Shouldn't the price go up too? Why? The higher the earnings per share, the higher the demand for that stock. And higher demand for the stock would push up the price, right? That's the intuition. But mathematically, it's, it becomes quite obvious. So if, this is Gordon growth model, and just putting it to price, next period, right? And then if you just rearrange some terms, what is this? This is exactly right. P0, right? So as expected dividend at time 1 goes up, then price would have to go up, right? It's a mathematical, because whatever goes up in the numerator will pull up the entire fraction, right? So this is the mathematical verification of that. And discounted cash flow model is, a broader concept than DDM, this dividend discount model. We infer, required return or cost of capital for stock with market price at time 0. Then this is intrinsic value, right? Because discounted cash flow model is based on, literally discounting, and discounting uses, given, right? The required return is calculated from basically solving for internal rate of return, right? From discounting all future cash flows, right? So it is determined, from the model. Now, intrinsic value uses, expected return. But think about it. Intrinsic value is, um, again, it's the same process, right? Um, you're discounting all the expected future cash flows. Expected. I mean, future cash flows are all expected. So theoretically, we we use, expected discount rate, or required return, which is basically the same thing as cost of capital, because there is only one number, one internal rate of return that makes right hand side equal to the left hand side. Okay. So basically, solving the one period compounding model for expected return, you get cost of capital, right? Cost of equity, right? This is cost of equity. All righty. So our time's up. So I'll have to stop the video, stop recording, and I will see you guys in the next video. All right. Thank you for watching, and see you then.